In question 1, the problem statement says, draw different pairs of circles. How many points does each pair have in common? And what is the maximum number of common points? So I'm going to show you a simulation to help you visualize this. We are going to consider different configurations of two circles, and we are going to find out how many points are common for each pair, for each configuration, and we're also going to figure out what is the maximum number of common points that are possible between two circles. Okay, so here's a simulation that shows two circles with their respective centers. Right now the circles don't intersect each other, and the circles lie completely outside of each other, and in such a configuration the circles have no point in common. So as long as the two circles stay outside of each other, they have no point in common. Now let me bring this smaller circle closer to the larger circle, and at some point the two circles will just touch each other, and in such a configuration there is one common point, the point at which the two circles touch each other. If I bring the smaller circle any closer like this, then the circles start to intersect each other, and in such a case we have two common points, this and this, and this configuration is there as long as the two circles intersect each other at two different points. We have two common points. Now if I take the second circle, the smaller circle, inside the larger circle like this, at some point the smaller circle will touch the larger circle from the inside, so we again have one common point. And if the smaller circle lies completely inside the larger circle like this, then we again see that there are no common points. So there are three possibilities in terms of common points. The two circles could have no common points, and this happens if the two circles lie completely outside each other, or one circle lies completely inside the other circle. In such a case there is zero common points. There could be one common point in case the two circles touch each other. This could happen externally. These two circles could touch each other from the outside, or one of the circles could touch the other circle from the inside like this. So in such configurations there is one common point. Finally, if the two circles intersect each other, we have two common points. So the maximum number of common points that two circles can have is 2. So summarizing what we saw in the simulation, we saw all these various cases. In this first case, case 1, the circles don't intersect each other at all. So in this case there are 0 common points, and this happens if the two circles lie completely outside of each other, or one circle lies completely inside the other circle. This case 2 is when two circles touch each other, in which case there is one common point, and one circle could touch each other, the two circles could touch each other externally like this, or one circle could touch the other circle from the inside like this. And then finally we have case 3, where the two circles intersect each other, so they have two common points. So two circles can either have 0 common points, 1 common point, or 2 common points, but not more than 2 common points. So the maximum number of common points two circles can have is 2, and this is the answer to question 1. And now there is one final point I want to make. Some of you may think that if we have two congruent circles which lie on top of each other, then they will have infinitely many common points. If we have two congruent circles completely overlapping each other exactly, then they have infinitely many common points. So the actual answer of the maximum number of common points should be infinite and not 2. But actually that's not correct, because technically speaking, if you have two congruent circles which are overlapping each other exactly, then those two circles are actually identical. They are the same circle. So they are not different circles, and they are not a pair of circles. So the actual answer to this question is 2 only. So please keep this in mind. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.